Hello, welcome back. So today, as part of a data modeling masterclass series that we are having, so we are bringing one more video, and this is one of the most important video, and we will be discussing about normalization. So the normalization comes under logical data modeling. So there are, like as you saw in the previous video, there is a conceptual data model, logical data model, and then actual implementation where physical data model is there. So normalization is part of like data modeling. So it is one of the important topic. So this is simple if you understand with the examples and if you can visualize this, right? So if you cannot visualize the topics or you cannot digest the topic, so then it looks a little complicated. So that is why I would recommend you to please watch the video till the end. So we will be explaining the different like normalization. So what is the benefits of normalization? What if we don't do the normalization, right? So we need to understand the benefits, and if you don't do the normalization, what is the implications of that? And then we will briefly discuss about first normal form, second normal form, third and BCNF normal form, and fourth and fifth normal forms. So please watch the video till the end, and if you are new to this channel, we would recommend you to please subscribe and also press bell button for instant notifications. So let's get started. So if you look about the normalization by definition, right? So normalization basically it's a database design technique, right? Used to reduce the redundancy and dependency by organizing the fields and table relationships. So it is actually, if you look at the high level, so if you want to understand what exactly normalization is, right? So it's nothing but you are just reducing the redundancy and dependencies by organizing the fields and table relationships. So it is just about that. So whatever normal forms you 1, 2, 3, 4, 5 and BCNF normal form. So all the normal forms, what they're actually doing is they are reducing the redundancy. So if you so the intention is to reduce the redundancy and dependency. And how do we do that? By organizing the fields and the tables relationships. So maybe one table might be split into two tables or three tables, right? So using the different fields and the relationships, okay, that they have. And the process involves the decomposition of a database table into two or more tables, and defining the relationship between these tables. Suppose take for example there is a table here, right? So there's a maybe employee table or whatever table it is. So and this table can be split into two tables. Okay, so maybe employee table and say department table example. Okay, so basically this is what you are doing, a decomposition, and one table is getting decomposed into multiple tables or like two or more tables for that matter, and the goal of normalization is to ensure that each table contains data about the only one type of entity, thereby eliminating the redundant data and improving the data integrity, right? So data integrity is again very important, right? Like if you are storing the data, like if you have we will see in the next coming examples, but these are the important things. And so this is by definition, you need to understand this, right? What exactly we are trying to do here. So the important point is the decomposition, right? You are decomposing the tables, and it is a database technique used to reduce the redundancy and dependency. Okay, how do you do that? By organizing the by tweaking the or tweaking the fields and their table relationships. So this is normalization by definition. Okay, and normalization is typically carried out through a series of steps that is called as normal forms. That is called normal forms. So there are different normal forms: first normal form, second normal form, and so on. So that we will see one by one. But before that, let us understand the purpose of normalization. So this is kind of important, right? So why exactly we need to do the normalization? Yeah, like you say, the normalization is one of the key important techniques, so that's agreed. But why we need to do this? So the first and foremost, the key aspect is reduce the data redundancy. Okay, so by organizing data into a separate tables and defining their relationships, normalization minimizes the repetition of the data. So that we will again see with the examples. But so that is a key intention. This helps in saving the storage space and maintaining data consistency. So it saves the space and also it maintains the consistency of the data. And what is the improve data integrity? So data integrity is basically normalization ensure that the data dependency are logical and correctly enforced by data structures. So basically it actually maintains the key value pair, foreign key, primary key relationships whenever it splits the data or decomposes the table into multiple tables. So that will reduce the chance of anomalies during the data operations, such as like insert, update, and delete anomalies are there. So we will again see in the with the examples, but that is a key purpose of normalization. And simplify the database maintenance. So with a well normalized database, so changes the schema, maybe like adding a new field or updating existing ones, will become easier to manage without affecting the entire system. So that's how it simplifies this, right? And next is enhance query performance. So though sometimes normalization can lead to complex queries because we are decomposing the tables, and to build a report we need to join the multiple tables, so that becomes a complicated query. uh, it generally enhances the performance by reducing the size of the data set. So that's the other part of it, right? That also we need to understand. It may sometimes complicate the query, but end of the day it is reducing the size of the data set that needs to be scanned, right? So on the paper, if you see the query, it might look complicated, but when you give that to a database, so the performance is better, because the time that it needs to be the data scan, because the data is not redundant, it will be very fast, especially when there is a you need to define the table indexes properly. So in that case, definitely it increases the query performances. And facilitate data integrity and consistency. So normalization ensures that the data modifications like inserts, updates, and deletions are made in a single place, so thereby maintaining the data integrity and consistency across the database. So that means integrity and consistency is nothing but, so if you're updating a particular department ID, so it should be in one place. You should not update in 10 different places. If you are updating in 10 different places, so then there is a possibility of um, data inconsistencies or and data integrity issues. So, and we have seen the purpose of normalization, and also we see consequence of not normalization, not normalizing, or not using the normalization concept, right? So these two concepts we are taking at the first of this video, because beginning of this video, because first you need to understand the objective of normalization. So then you will get the motivation to learn exactly what exactly the you will learn the importance of normalization, and then you have that motivation to learn the different forms of normalization, right? So now, what is the consequence of not normalizing? So so it might be lead to a data redundancy. That means without normalization, the same data may stored in multiple places. So this redundancy can increase the storage requirements and can lead to inconsistencies in the data. Is Data is not updated simultaneously in all the locations, right? Because if the data is redundant, so there is a possibility of inconsistencies, right? And update and insert anomalies. So if the data is duplicated in multiple places, updating one piece of information requires multiple changes or failure to do so can result in data inconsistencies. For example, if an employee address is stored in multiple table and updates in only one, then the database can end up having an inconsistent data, right? Similarly, insert anomaly, right? So without normalizing inserting a new data can be a problematic and tricky if certain piece of the data are missing. Let's take for example, if a new course need to be added in a student database, the database may require other unnecessary information to be added as well, leading to null values or dummy entries that you may need to do. So for all of this, we will take examples, but now just these are the pointers you need to just take a note of this. And delete anomaly also similar to update insert anomaly. So deleting data can inadvertently remove other necessary data if the database is not normalized properly. For example, deleting a record of a student who is the only one who is actually the only one enrolled in the course might also be removed. Might also remove the course detail if they are stored together. Okay, got it right. So, and complexity in data management. Managing a non-normalized database can also lead to become big database can become complex, especially as the volume of data grows. Changes in the schema, bug fixing, and data integrity checks can become challenging, right? And finally, we have the performance issue. So performance issue, although normalization aims to optimize the query performance, non-normalized databases might initially seems faster for certain read operation because they are reducing the number of joins because there will be less number of tables. However, the increased data volume due to redundancy can lead to slower performance in the longer run. Okay. So now let's take example of consequence of not normalizing. So we will take example and understand how exactly a particular non-normalized table and how that can lead to many issues, right? So let's take a famous employee table as example, right? And so we have an employee ID, employee name, department ID, department name, manager ID, and manager name here as attributes in this employee table. And so redundancy and inconsistencies, right? So we will just go through these steps, whatever we have seen in this previous video. So first we will go about the redundancy, right? So how this can lead to redundancy. So redundancy, you can take example here, right? So the department name and the manager name. So if you take these two columns, are repeated for every employee in the same department. Suppose a particular employee is in the same department, right? So 101, 102. So these two guys are in the same department. So this value is repeated 101, 101. And for this department, so the manager is manager ID is same, manager name is same. And you can understand this importance. So this all the four all the yeah all the four attributes, if we consider, it is actually repeating. And now it might not seems um, more impactful, but let's consider instead of 3 rows we have 3 million rows. So then you can understand, instead of it taking 100 MB of size, it can take maybe like 1.5 GB of data, because just because of that you are not normalizing this and you have the duplication data here. So this is example of data redundancy, right? And now let's discuss about the anomalies, update, insert, and delete anomalies. So, so now if you want to talk about the anomalies here, right? So anomalies are basically, if you take update anomaly, so if the HR department department name changes. So let's take example here. So this particular HR is there, right? So if the HR department name changes, it must be updated in every row where it appears. So this particular HR name changes like to HR underscore one. So again, it has to change it here HR underscore one. So again, if you have 304 million, 304, 3 million, 4 million records, so then you can imagine, so all those rows has to be updated, and even a miss of one particular row might lead to data inconsistencies. And similarly, the insertion also, right? Adding a new department. Suppose you want to add a new department here called XYZ, right? Or finance, right? So if you want to add a finance department here, so then even in that case, without employee, so first you need to create a finance department, and so let's take example, you don't have any employee. So then you might end up inserting null values here or blank values here, right? You just need to, yeah, these two will be blank, and here only this one, two, and the manager also might not be there, even this can be blank. Okay, so that's where it is leading the anomaly in insertion also. So that is leading another inconsistency of data here. And even in the delete case, so deleting all employees from my HR department would also remove the department details and losing the important information. Suppose HR department is now no longer relevant, so you just delete that HR department. So by deleting the department, so this particular employee will become orphan, right? And or the other cases would also get removed from the department details, losing the important information. Okay, so these are the anomalies that can have in this employee example, right? Employee table example. So next is, so we can see complexity in data management. So with all these examples that we have seen, definitely the complexity of managing this particular table will be a real headache, right? If the as the volume grows. And the last is the performance issue. Suppose let's take example like you want to write a query on top of this table, and because of the duplications and whatnot, so it might lead to a lot of performance issues. And considering 8 million, 10 million records, so fetching this report out of this table would be a really time consuming operation.
We will cover the normal forms in the next video. Thanks for watching.